for attending, and thanks for the opportunity. Yeah, analytical perspectives in hemp. Like, this is just a long title for the fact that we've done a lot of CBD, hemp, and marijuana testing over the years. Specifically, I'm going to talk today about some of the perspectives that we've seen looking at cannabinoid potency, or like the actual cannabinoid content of samples. Just a little background about me and EVIO Labs. They shouldn't listen to me just because I'm up here on the panel. Have a lot of experience in natural products and natural product chemistry, but also nutraceutical quality assurance and manufacturing. And I started a licensed analytical cannabis lab in Oregon about 5 years ago. And over time, we've slowly morphed that concept into EVIO Laboratories, which is a North American company offering analytical testing services, both informational R&D testing, but also, state-required compliance testing for marijuana, and also more now than ever, hemp and hemp stuffs. So just kind of broad outline of this talk is that I want to talk a bit about what cannabinoid testing is, how it's done, why it has value. Talk a little bit about why CBD in particular, not just because we're at a CBD conference. And then more importantly, I think at the end, like the last half of the talk, I have some what I think are important findings, or things that we've distilled from testing almost 17,000 different samples for CBD and cannabinoids over the last couple of years, just in our Oregon operation. So the data I'm presenting today will just be things that have come out of Oregon. And then if you have any questions, this is a pretty intimate audience. We'll have time after, but don't hesitate to raise your hand. We can go in discussion mode. So yesterday at the panel, Dr. Silva correctly pointed out that testing or enumerating the amount and type of cannabinoids in a sample is technically not potency, right? Potency is a metric of how strong a drug or a medicine is, and so calling our test cannabinoid potency is a little bit of a jump, because we're really just metricing the amount of cannabinoids in a sample. There is a presumption, or even maybe an understanding, that the cannabinoid content is, the medicinal effect, so it's sort of colloquially referred to as potency. And how does this relate to hemp and CBD stuff? Well, at the beginning of the supply chain, most departments of agriculture in states where hemp is grown lawfully have a industrial hemp program. And so in order to do that, you probably already know this, you must register as a licensed hemp grower, and you're required to have your material tested while it's still standing in the field, to verify generally that it's below 0.3 or 0.35 in the case of Oregon THC content. And that is really the only benchmark for, at least to a chemist, what hemp is, right? These are all cannabis plants. That's not really scientifically disputed anymore, but we call things that are below a certain level of THC hemp, and everything else is marijuana. So secondly, along the supply chain, we test tons of hemp flower, or even just hemp biomass that's ground, milled, pelleted, etc. And then why does this happen? This is really just for commodity quality insurances. You got to know, if you're going to consume it directly, it's important to understand how much cannabinoids in it, or even if it's going to extraction. Measurement of cannabinoids is really the benchmark for the perceived recovery, or the amount of extractable mass that you can get from hemp, right? If it's roughly 10% cannabinoids, you're going to be looking for 9 or 9.5% by weight of extractable resins. If it's 15% cannabinoids, you should be looking for somewhere in 12 to 15% by weight of extractable cannabinoids. So honestly, that is probably like the bulk of the type of cannabinoid data that we see for hemp and CBD these days. Secondly, once, because purified CBD is very, very popular, it's a highly desired commodity. So most of your hemp flower and biomass, while some of it is probably smoked or vaped, most of it these days is really extracted into resins. That's kind of a chemist word too. Everyone calls it oil, like hemp oil. But again, like hemp oil, like the seeds really produce oil, and so to chemistry guys, oil means like a fat, and so for whatever reasons, I'm always calling them resins because they're different than oil. And CBD seed oil, or hemp CBD, hemp seed oil, contains little or no cannabinoids ever, right? It's a different commodity. So once extracted, you have all different types of crude but also refined forms of hemp resins. These are generally very, very rich or even pure in CBD. We benchmark these all the time really as like a commodity quality. Also for yield estimation for things like distillation and other polishing. Also for formulation calculation in the sense that if you have a kilogram of some 80% CBD product, you need to know how many gummy bears at what level of dose per gummy bear. So assaying cannabinoids and CBD resins is really important if you're making infused products. And and then finally in the supply chain, we do a lot of testing for hemp and CBD infused products. This is primarily, looking at dosing strength, but also dosing consistency, and also homogeneity within the product. The example here is the gummy bear, and if you eat half of a gummy bear, there's a presumption you would get half of the dose, but if all of the CBD milligrams are in the head, well, that's a non-homogeneous product. So homogeneity per unit, but also within the batch is very important. These are all concepts that come straight out of not only pharmaceutical, but natural product and nutraceutical manufacturing. There's a presumption that if you market a product with some discrete dose that's standardized, that every single dose is going to be very consistent in the delivery of the target compounds. We're also looking at stability and also research and development. I was going to say harder than you think, but if you guys are actually manufacturing CBD products, you actually know it's rather difficult to get cannabis resins in general dispersed into foods that we eat without making it taste really nasty or making that resin completely non-bioavailable because it sticks to the package or sticks to the the gelatin. It's possible that you can infuse things into a food so much that they just pass through your digestive tract, and then the cannabinoids don't have access to your bloodstream. So what are we testing for? I thank Jake for introducing a fair bit of these compounds already. What's most typical are your THC and CBD and their conjugate acids. Also CBN, which is a natural degradation product, primarily of THC, but also CBD to some extent. Most laboratories running cannabinoid assays will have at the very least these, and then quite a few of what we call the trace cannabinoids. These are CBC, CBG, THCV, CBDV, and their acids. You've also heard of delta 8, which is similar to delta 9, but it's the delta in CBD and THC relate to where this double bond is within that upper ring. And then there's some, some really odd, super rare cannabinoids that, like Jake alluded to, we're not even sure if the plant actually synthesizes them. Some of these are oxidative and other enzymatic products like cannabicyclol and cannabizoin. So these are trace cannabinoids that you'll sometimes see on lab certificates analysis. They're generally very low and rare. Not to say that they don't have therapeutic or medicinal interest. How do we test cannabinoid potency? Gosh, 100 years ago, I used to work for a little herbal company, and we used to do all kinds of thin layer chromatography. And this is what you learn like in your first organic chemistry lab. It's literally like a plate with like a white powder in it, and you can submerge the plate in some solvent, and then as the solvent kind of wicks up, it separates compounds, and then you can dye them with different stains. And you can actually get home test kits that are pretty easy to operate and do pretty accurate estimation of THC and CBD, at least in straightforward matrices like resins or concentrates and flower extracts. You try to test things that are sugary or fatty, pretty much things fall apart with thin layer. So thin layer, very simple, very expensive, useful to some extent, but not in a high throughput laboratory. Back in the day, most of your cannabinoids, back in the day meaning even 5 years ago, were tested on what's called a gas chromatograph, right? And so heated gases are passed through a little tiny tubular column. The compounds separate and then go into like a little flame detector, and then we can measure like the electrical signal of the flame, and that gives us peaks, right? The downfall of a gas chromatograph in modern testing is that it doesn't recognize the cannabinoid acid forms because of the heat. Generally, the acid decarboxylates in the inlet, so you can't really get an accurate snapshot by any stretch of the acids versus the decarboxylated forms. There's some technical ways around that called derivatization and stuff, but it's convoluted and expensive. So relatively low complexity. I first tested cannabinoids as an undergraduate in the organic chemistry lab on a GC. We didn't have standards, but we were, you could inject them in, and you could tell because like the swaggy brown weed would have 2 peaks, and we could tell that was probably CBD and THC, where your really bright green colored like indicas and stuff would have this very large peak, and so we just deduced that was THC. That was all super fun, 25 years ago. And then, before I started a laboratory, I actually had a GC in my garage because I had all kinds of friends who were like breeding and growing. It was super fascinating to try and find out how much was in these things. And so it's fast. But again, limited on matrices. Again, not very simple if you want to test things like gummy bears and cookies and chocolates. Those things don't work well in a gaseous environment. It tends to just clog the machine and kill it. So after about 2015 or 16, you see very few cannabis labs doing GC cannabinoids. It's just not flexible enough. So liquid chromatography is a similar concept, but instead of passing hot gases through a column and needing to volatilize your cannabinoids, they're pumped with solvents through a solid column. The nice part of this is that it happens at ambient temperature, so you can easily resolve your acid forms versus your decarboxylated forms. Really robust for sample cleanup, no problem at all to inject things that are sugary or oily and things like that. So pretty much all of your modern cannabinoid measurements in modern labs are performed on a HPLC, high pressure liquid chromatograph. Generally use what's called UV detection. shine a wavelength of light, each of the cannabinoids have like some special absorbance depending on their wavelength and their shape and size. And so we can measure that and get peaks. Sometimes you see a mass spec used, and I'm not going to talk about what a mass spec is, but you can get better sensitivity, I think, out of a mass spec for really, really, really trace level cannabinoids. But they tend to just get pretty swamped out and like oversaturated if you're looking at major cannabinoids. So, mostly HPLC with UV. Well, that's the universal good, fast, and cheap. I don't think that needs a lot of explanation there. So why is routine, and I'll say accurate, CBD testing important? Well, there's a long list of stakeholder concerns, right? If you own a company or a distributorship or a farm, it's important to you not only to understand the strength of the medicines and products, but also the consistency. And that is a data-driven thing. Nobody in manufacturing is crossing their fingers that their stuff is consistent. So everybody involved with making and distributing products should be really concerned with, how accurate the dosing is in their product. And then there's all kinds of, I would say, consumer and public health concerns. Unlike THC, I think if you eat a little so-called too much CBD, it doesn't tend to cause toxic psychosis. I think that's the clinical term for if you take too much THC and you're freaking out. Even still, it's important if somebody is using a product in a therapeutic fashion that not only the next gummy bear or the next pill in the package, but the next time they go to buy a new package, that they're getting a consistent dose. I mean, people are legitimately medicating themselves and have particular expectations. So obviously important on that end. And again, back to like what's being tested and why in this context. Hemp biomass for certification, but also looking at chemotype. There's a lot of interest in hemp stuff that has CBDV and other minor cannabinoids. And also resin yield, right? If you have a train load of 9% CBD hemp biomass versus a train load of 15%, it's a very different amount of yield that you're going to expect from that product. Again, with concentrates, refinement meaning all the polishing and cleanup that's going on with all these resins, distillations, etc. All that requires a lot of R&D and measurement of ongoing outputs to kind of get their processes ironed out. Trace THC is a really big thing right now in CBD resins, whether we're talking about crudes or distillates or isolates. It's pretty tough to get rid of the very last bits of THC. And then also, we already talked about infused products. So here's the more interesting part. Over the last couple of years in Oregon, we've performed over 16,500 potency tests. And I'm not going to share all of that data with you, but there's at least 4 things when I started about a month ago, like really grading through this data, like thinking about what I could talk about that might be important to stakeholders at a CBD conference, right? So I think whether you're a hemp farmer or a CBD product manufacturer or even a CBD consumer, hopefully there's something in here that might be of interest, right? So I'm going to talk a bit about CBD and other cannabidiols that we see in hemp products and different hemp things. We've got some interesting data about what we call pre-harvest certification. Then I'm going to talk a bit about what we call cannabinoid artifacts in distillates. Distillation adds a lot of heat and dwell time and pressures, and oddly enough, strange reactions and unknown reactions can happen in there. And then I'm going to introduce this concept of CBD stability in infused products. You probably have heard a little bit about that. We have some data to share. So in general, this is just a broad plot of a bunch of plant or flower THC tests from our database, just looking at each little X is a set of samples. And then that's the THC level, and that's the CBD level. And so classically, this is what we call your marijuanas over here. These are generally relatively high THC and limited CBD, but almost always find none. All your marijuana has a little bit of CBD in it. And then here's most of your hemp stuff. So like these are down here are probably biomass, relatively low overall potency, but little or no THC axis. So most of this stuff is your hemp, right? I would say 5 or 6 years ago, you didn't see a lot of stuff in the middle, right? You had the cloud here and a cloud here. What these represent are interesting samples, mostly I would say in the marijuana industry. These are classical marijuana strains like your OGs and Blue Dreams, and you've got some progressive breeders that are taking those strains and crossing them with various hemp strains and then looking to bring up THC a little bit. But a lot of it's for aromas and colors and things like that, which a lot of hemp strains sort of lack. So over time, we see a lot more interesting, like this cloud here that's not along the hemp axis or the marijuana axis. But obviously, a lot more marijuana samples than hemp, at least over the years. So what's typical in hemp commodities? Hemp biomass, these are fairly broad numbers. There's certainly outliers to this. CBD, you're looking at 0.5 to maybe 15%. THC, for our routine assay, 0.05 weight percent, I think is like the lower or limit of quantitation. So almost always there's some click or two of THC in hemp stuff, at times ranging even up to 5%. In crude resins and extracts, CBD in probably the 20 to 60% range. Always still maintaining a little bit or sometimes a lot of THC, depending on where that comes from. Polished resins, so this here I'm talking about basically distillates and other de-waxed and defatted resins. Potency gets up quite a bit higher, ranging up to maybe 85%. And then here's where you start to see some trouble, I would say, in the supply chain, is a lot of these polished resins come out, that would qualify federally as hemp, but a lot of them have, 2, 3, 4, 5% THC in them. And now, even though it's hemp derived, it doesn't qualify as hemp anymore, right? I mean, once you have an extract, you can say it was derived from hemp, but like the definition of hemp is all revolved around THC content, right? So a lot of interest in industrial chemistry processes to like selectively strip THC while leaving everything behind. Distillation and isolation gets around some of that, but it's not actually, the last few percent are the hardest to remove, right? It's just a fact of chemistry. Isolates, all the way up to near 100%. I didn't write 100% because, honestly, if you're measuring this stuff on an HPLC, if you have a sample that is 99%, like statistically, when you measure it repeatedly on an HPLC in that method, sometimes it'll say it's 103%, right? So without doing what's called a peak purity assay on top of an HPLC, we don't really report things above 99%. It's just not accurate at the top as it's not accurate at the bottom. Yeah? Yeah. Well, I mean, that's why on our reports, basically, we have like a data rule whatever value you put in there that's above 99, it's going to print 99 or great. Sometimes it says greater than 99%. So to measure something in an HPLC, you assume that you're going to measure a component of what's in the mix, right? And so it's not accurate at very, very, very low levels, but it's also not accurate at the top, right? If you assume something is a component and then your assay is inductive, meaning you're going to say, well, what fraction of the pie is each component? Statistically, what you'll find out that if something is not a fraction, it is all, your measurements are going to be on both sides of 100%, right? So 102%, that's a statistical anomaly. It might be 100%. It's probably 99 point something percent. But yeah, when you assume it's a slice of a pie, and now your model says, oh, it's the whole pie, yeah, it causes a statistical problem. In other worlds, you would do what's called a peak purity assay and now assume it's a different method. Assume that it's not a fraction of THC or CBD, but assume it's pure and measure whatever in there is not CBD. So you have to deductively measure it. That's why it says 99, right? And then THC, non-detect to, I mean, some isolates are just depending on the skill and also the physics of the distillation rig. Or sometimes it's not distillation, sometimes it's flash chromatography. Sometimes, it's just leaving percentages of THC in there. I threw this in here because this was super fascinating. Doing a little research just last night, actually. Why is CBD important? Well, hemp-derived CBD are these blue columns, and we find ourselves here. So we're looking, I think, at this year, looking at a $350 million industry. This is a stat from Frontier Financial, and interestingly, I mean, they're showing that like CBD from the marijuana industry is like of similar volume. But more surprising to me, I didn't realize that Epidiolex, so this is pharmaceutical sourced on the top. It's already a $30 million drug. Epidiolex is a CBD THC mixture, yeah.
Let me get you this mic here so we get it on.
The last diagram you showed, hemp, CBD, 5% THC, hemp can produce that much THC?
Well, I would say you will find plants and materials in hemp fields that can produce that much THC. Technically, those are not hemp anymore because, this 0.3 is the designation, right? I mean, there's genetic signatures for different strains of
So
hemp.
then it's no longer
It's technically not hemp.
Okay.
It comes from the hemp commodity sector. Yes.
Okay.
On the last slide there where you show the 5% on the THC, as it gets more distilled or it gets further processed or refined, does that have a tendency to increase the concentrated levels of THC automatically, or is this just a fluke?
It's generally kind of a fluke, because when people are distilling hemp resins, they really want to get rid of, they want to purify CBD. The problem is, I mean, this is a little technical, but a lot of the distillation technology in the hemp space for hemp resins are short path distillation rigs that have, tried and true for the last 5 years in purifying CBD or THC. But if you want to get 85, 90% THC, you really don't care if there's 1 or 2, 3% CBD in there. And in truth, short path rigs and other relatively short fractional distillation heads are not efficient at separating the last bits of THC from it. You either need a really tall fraction still, or a different technology. So I think the intent is through distillation is to get rid of THC, but in reality, a large percentage of them, unless you're a pretty badass industrial chemist, end up going the other way. And you still, turn up the CBD, but it's pretty tough to separate the last few percent. This is a weird projection. They're saying, at least this financial group, nearly $2 billion CBD industry just ahead, equally split between hemp-derived, marijuana-derived, and pharmaceutically derived CBD. Thought that was interesting. Okay, let's talk about, how am I time? Industrial pre-harvest testing, right? In Oregon, the Department of Ag manages all this. You get a license to plant your field. Before you harvest, you must get the material tested. This used to be done only by Department of Ag scientists. Today, most of your licensed cannabis labs, at least in Oregon, will do this on behalf of the Department of Ag, so we have the permits to do this. The rule is based entirely on Delta 9 THC. We'll get to that in a minute. It must be below 0.35. I think the federal deal is 0.3. If it's under 0.35%, you get this 30-day window to harvest your material. So what does that look like? This was 512 different pre-harvest samples that we did beginning at the very end of 2017 and then up till just a couple weeks ago. That's where this data comes from. Here's your main cannabinoids, right? CBDA ranging from next to nothing all the way above 20%. CBD ranging kind of where you expect it, up to around the 6, 7, 8% range. THCA, often above 5%, even in true hemp stuff. And then your Delta 9, always down pretty low. Well, if we zoom in a little more on this data, just focusing on the THC and the Delta 9 and the THCA, well, here are that's that same data, just expanded, right? And here's the Oregon limit. And so that line is the mean, and then this is your standard deviation, these little bars, right? So the mean is well under, and in truth, most samples that we test in Oregon for pre-harvest actually pass and go on to be harvested. But there's the Oregon Department of Ag is talking about changing this rule because, as you can see here, if you're just looking at Delta 9, there's a lot of available THC that they're just not really considering in their rule. And so they're talking about doing something called total THC, right? And what is total THC? You see it on a lot of certificates of analysis. Essentially, when you decarboxylate THCA, you lose about 13% in weight, like the weight of CO2 goes off of the molecule, right? So if you take this ratio of THC to THCA, it's about 87%. So that THC is about 87% of the molecular weight of that, right? So you can calculate a theoretical total THCA by having both of these measurements with this equation. And in marijuana, this is a big thing. It's almost all the states do this. This is the rule. 87.7% of the THCA plus the THC gives you this total THC. So in theory, total THC would be like if you decarboxylated completely, you would get that number. Well, so here's all those 512 samples, right, that we've done. Fail rate well under 10%. Fail meaning above 0.35% Delta 9 THC. If Oregon Department of Ag changes their rules to do total THC at 0.35, this is that same data set modeled to fit that rule. If they put it at 0.3, which is the federal limit, yeah, it's like 70%. So there's some things to figure out here, because really, like today or for the last couple of years, most anything you plant in a hemp field can be certified as hemp. That's going to change a lot of things. There's a lot of, I think, valuable hemp strains that aren't going to be commercially grown anymore because of that. Artifacts. We used to see artifacts in THC distillates, right? These unknown peaks. Well, I'm going to go a little bit quick. It also happens in CBD distillate. Basically, what we have here are 2 crudes and then like a refined or like a sample that's been passed through distillation. And then so that one's hard to read. Let's check this out. All right, so this pink or purple line is this distillate, where these brown and green lines are the crude feedstocks that went into that distillation. And this is interesting because I zoomed out of the CBD peak, but like this client was really upset that their distillate, their CBD content went down. And lo and behold, it had delta-9 THC in it when the crudes had very little, right? And so what's happened is that like through heat and uncontrolled temperature reactions, you get an unknown cannabinoid, CBD manufacture, another large unknown cannabinoid, and then the delta-9 progressively goes up as it's been distilled, right? So you have to be a really good distillation artist to keep this kind of stuff from happening, and a lot of people know about it in THC distillation, but it is definitely a thing with CBD distillates as well. And then the last thing I want to talk about, this is stability. Like if you're into manufacturing infused products, this is important. Back in the 60s, Dr. Meshulam from Israel postulated, actually they showed in the lab that you can isomerize CBD to THC. It's not that difficult. It can happen spontaneous under some conditions. And then some of this information I also get from this really cool paper that came out a couple years ago called Phytocannabinoids, a Unified Critical Theory. If you're into cannabinoids, you should check that paper out. So basically this reaction can go either way, right? Where THC can, under base conditions, isomerize the cannabidiol. But it's been postulated that this can happen the other way. So a lot of people who have taken CBD products say that they experience some THC intoxication. Well, so people postulated, well, maybe under the acidic conditions in the stomach, you can get CBD isomerization to delta-9 THC. That's never been clinically proven, but a couple years ago, some water scientists, Dr. Layton presented this at Emerald a couple years ago, where they tried to synthetically induce isomerization and to mimic like a product, right? So we do a lot of stability studies for infused products and beverages and tinctures and things, really because of this paper. And what they did was they did accelerated shelf life testing. So these are just overlaid chromatograms, right? And so on the bottom is your control. Here's your CBD peak, and then delta-9 THC. You see there's basically none in this product. Under oxidation or